Write in figures the number 20,020. So write in figures means the same thing as write in digits. And the way to write numbers in digits is to read the number up to the word thousand. We have 20,000, so we can write 20 and then we can have a comma to separate our thousands and our hundreds place. Then we read the rest of the number after the word thousand. We have and 20, but we need to write 20 using 3 digits because we need digits for our hundreds, tens and ones. So we need to write 20 as 020. That way we've got 2 in our 10,000s place, so that stands for 20,000, and we've got 2 in our tens place, so that stands for 20. Michelle has saved £8.40 in 20p coins. How many 20p coins does Michelle have? So one coin is 20p, but if we times that by 5, 20 times 5 is 100, so 100 pence is £1, so 5 20p's would be £1. But now, if we times by 8, we can find out how many 20 pence coins make £8. So 5 times 8 is 40. That means that 40 coins means £8, but we want £8.40. Now if we multiply 20p by 2, we get 40p, so 2 20p coins make 40p. 40 20p coins make £8. So if we put that together, we get 42 coins making £8.40. Now the other way to solve this question is to change £8.40 into pence. £8.40 is 840 pence. So then, because she saved that in 20 pence coins, we can divide 840 by 20. Remember, when we have division questions where both the number we're dividing and the number we're dividing by end in zeros, we can cancel our end zeros. So here we can just work out 84 divided by 2, and that gives us 42. So we know that Michelle must have 42 coins. Draw a line to join each fraction to a percentage of the same value. So we need to remember that percentages are fractions which have a denominator of 100. So to find an equivalent percentage for a fraction, we need to find an equivalent fraction with a denominator of 100. So for 1/4, 4 times 25 is 100, and 1 times 25 is 25. So because 1/4 is equivalent to 25 hundredths, 1/4 is the same as 25%. Now we have 1/10. So again, we can find a fraction which has a denominator of 100. 10 times 10 is 100, and 1 times 10 is 10. So 1/10 is the same as 10%. And then we can see that they've done 1/2 for us. 1/2 is the same as 50% because 1/2 is equivalent to 50 hundredths. Here is a 1 centimetre square grid. Some of the grid is shaded. What is the area of the shaded shape? Now the area is just how much stuff there is inside a shape, and because it's drawn on a square grid, we can find the area just by counting squares. But this question is a little bit more confusing because we have some squares that are half shaded. So we need to remember that 2 halves make 1 whole. So these 2 half squares make 1 square, these 2 half squares make 1 square, so altogether that's 2 square centimetres, and then we can count 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the shape takes up 12 centimetres, which means that the area of the shape is 12 centimetres squared. Now the question says, here is a 1 centimetre square grid. But obviously on the screen that you're watching this, 1 square won't necessarily be 1 centimetre, and also in the question booklet I've given you, because I've scaled down the question, what you can see in your question booklet is actually slightly smaller than 1 centimetre squares. This weather chart shows the highest and lowest temperatures in a town on 5 days in March. Which day has the greatest difference between the highest and the lowest temperatures? So let's look at each day and find the difference. On Monday, the highest was +7 and the lowest was 0, so that's a difference of 7. But then on Tuesday, the highest was +7 and the lowest was -2. So here we need to find the difference between a positive number and a negative number. And the way to do that is to just ignore the signs and add the numbers. So 7 plus 2 is 9, so +7 and -2 have a difference of 9. Then we have +8 and -2, so again we've got a positive and a negative number, so 8 plus 2 is 10. Now on Thursday we have +9 and +1. So here we have two positive numbers. So to find the difference between two positive numbers, we subtract, and 9 minus 1 is 8. And then on Friday, we have +4 and -5, so a positive and a negative, which means our difference is 9. So 10 is the largest difference, and that was on Wednesday. So Wednesday has the greatest difference between the highest and lowest temperatures. Now, what is the difference between the lowest temperatures on Thursday and Friday? So we have the lowest temperatures in this column here, and if we find Thursday and Friday, we can see that we're comparing +1 and -5. So we're comparing a positive number and a negative number, so we can just add to find the difference, and 1 plus 5 is 6, so the difference is 6 degrees. But to see why we do that, so why, if one of the numbers is negative but the other is positive, we add to find the difference, let's look at a number line. We can write -5, and then to get from -5 to 0, we need to add 5. But then from 0 to get to 1, we need 1 more, so we need to add 1. So altogether, to get from -5 to 1, we can add 5 and then add 1, so that's adding 6 altogether. So that's why the difference is 6 degrees. So why we can just add the numbers if one is positive but the other is negative. Here is part of a net for a cuboid. Draw in the missing face to complete the net. So we could have our missing face up here, and we need to make sure when we're drawing the face that it's 3 by 6, because our other rectangular faces are 3 by 6 squares. So if we draw our face up here, then this part here, this rectangle here, can be the base of our cuboid. This bit can fold up, this bit will fold up, this part here will fold up, and then this part down here will fold all the way over and cover the top, and that means this square here will be on this side of our cuboid. There is another possible answer for this question. We could have our missing face down here. That way, this rectangle here is the base, so this can fold up, this can fold up, this will fold up, and then our top rectangle will fold up and over, so be the top of our cuboid, and this square here will be on this side. Here is a number chart. Circle the smallest number on the chart that is a multiple of both 2 and 7. Remember, a multiple of a number is in that number's times tables, or can be divided by the number without leaving a remainder. So multiples of 2 are just even numbers, so numbers that end in a 2, 4, 6, 8 or 0. So let's look at multiples of 7. We know that 10 times 7 is 70, but 70 isn't on the chart. 11 times 7 is 77, but multiples of 2 are even numbers, and 77 isn't a multiple of 2, and we need a number that's a multiple of both 2 and 7. So if we add another 7, 12 times 7 is 84. So our smallest number that's a multiple of both 2 and 7 is 84. It's a multiple of 2 because it's an even number, and we know it's a multiple of 7 because it's in the 7 times table, because 12 times 7 is 84, or because we could divide 84 by 7 to get a number that doesn't have a remainder. So now here is the same number chart. Circle the largest number that is not a multiple of 2 or 3 or 5. So we want the largest number, and again we can remember that multiples of 2 end in a 2, 4, 6, 8 or 0, and multiples of 5 end in a 5 or a 0. So we know that 100 is a multiple of both 2 and 5 because it ends in a 0. Now to see if 99 is a multiple of 3, we can divide 99 by 3, and when we do that, we don't get a remainder. So 99 is a multiple of 3, and we want a number that is not a multiple of any of these numbers. 98 will be a multiple of 2 because it's an even number, it ends in an 8. So let's try 97. We know that it won't be a multiple of 2 because it's not an even number, and it won't be a multiple of 5 because it doesn't end in a 5 or a 0. So let's see if it's a multiple of 3. 9 divided by 3 is 3, but 7 divided by 3 is 2 remainder 1. So when we divide 97 by 3, we get a remainder, and that tells us that 97 is not in the 3 times table. It's not a multiple of 3. So 97 is the largest number on this chart that is not a multiple of 2 or 3 or 5. Write the coordinates of the next triangle in the sequence. So we have triangle A, triangle B, triangle C, so we need to write the coordinates of triangle D. Now to find where triangle D would be, what we can do is take a point on triangle A, and then if we look at the same point on triangle B, so here the bottom left, we can see that we go across 3 and up 2. Then to get to the same point on triangle C, we go across 3 and up 2. So we can go across 3 and up 2, and that will give us the point for triangle D. Now if we write the coordinates of this point, remember we look down first and then to the left. If we go down, we get to 10, and if we go left, we have 7, so the coordinates are 10, 7. Now to find the coordinates of our other points, either we can spot that it's 3 squares up or 2 squares to the right, or we could just take the different point on triangle A and do the same thing. So go across 3 and up 2, across 3, up 2, across 3, up 2. So our next point is here, and if we go down, that's 10, then across, that's 10, so our coordinates are 10, 10. And then for the last point in our triangle, again you can see that we're going across 3 and up 2 each time. So if we do that again, we get to this point here. Going down, that's 12, and across, that's 7, so our coordinates for this point here are 12, 7. And if we join these points, we'll get triangle D, so the next triangle in the sequence. 14 times 15 times 16 equals 3,360. Write the answer to 15 times 16 times 14. Well, that's going to be 3,360 as well, because with multiplication, order doesn't matter, and the same multiplicand, so the same numbers, are used in both questions. So multiplication questions will give the same answer whatever order the numbers are written in, and that's also true for addition. It's only with division and with subtraction that order makes a difference. Circle the percentage that is equal to 7/20ths. We need to remember that a percentage is a fraction with a denominator of 100. So we need to find an equivalent fraction to 7/20ths with a denominator of 100. 20 times 5 is 100, because 2 times 5 is 10, so 20 times 5 is 100, and with equivalent fractions, what we do to the denominator, we do to the numerator as well, and 7 times 5 is 35. So 35% is the same or equal to 7/20ths.